Welcome back to the channel. If you appreciate deep research, careful analysis, and serious conversations about extraordinary claims, subscribe to the channel, like this video, and share it with others who enjoy questioning reality. And before you leave, make sure you share your thoughts in the comments. Your perspective keeps this series alive. Now, let's get started with the episode. Tonight we step into one of humanity's most fascinating questions. Is time travel possible? Not in movies. Not in novels. In reality. The idea has shaped literature, physics, conspiracy theories, and even government rumors. But unlike many bizarre theories, time travel has something unique. It has mathematical foundations. Let us begin in 1905. A young physicist named Albert Einstein published a paper titled On the Electrodynamics of Moving Bodies. In it, he introduced what we now call special relativity. Einstein wrote, "The time required by a light signal to travel from A to B is independent of the motion of the source." That sounds abstract, but the implication was revolutionary. Time is not absolute. It can stretch. It can slow down. It depends on speed. This is not philosophy. It is measurable physics. According to special relativity, the faster you move relative to another observer, the slower time passes for you. This effect is called time dilation, and it has been experimentally confirmed. In 1971, physicists Joseph Haffel and Richard Keating conducted an experiment now known as the Haffel-Keating experiment. They placed atomic clocks aboard commercial airliners flying eastward and westward around the Earth. When the clocks returned, they were compared to stationary clocks on the ground. The result? The airborne clocks had shifted slightly, precisely as Einstein's equations predicted. The published results in Science concluded, the measured time differences are consistent with the predictions of relativity. Time travel to the future had occurred. Not dramatically, not by years, but by fractions of a second. And it was real. Let that sink in. Time travel into the future is not theoretical. It happens continuously to astronauts, pilots, even you, though at extremely small scales. NASA has confirmed that astronauts aboard the International Space Station age slightly slower than people on Earth due to both velocity and gravitational effects predicted by Einstein's general relativity. Physicist Brian Greene explains in his book The Fabric of the Cosmos, if you travel at speeds close to light, you can journey into the future. So forward time travel is established science. But what about traveling backward? That is where things become complex. In 1915, Einstein expanded his theory into general relativity, describing gravity not as a force but as curvature in spacetime. Spacetime can bend. It can stretch. And in extreme conditions, it may even loop. In 1949, mathematician Kurt Gödel, a colleague of Einstein at Princeton, discovered a solution to Einstein's equations that allowed for closed time-like curves. These curves would theoretically permit a path through spacetime that returns to its starting point. In simple terms, a loop in time. Gödel presented this solution to Einstein himself. Einstein reportedly found it unsettling. Gödel's rotating universe model implied that under certain cosmic conditions, backward time travel might not violate relativity. Later physicists explored similar concepts using wormholes. A wormhole is a theoretical tunnel connecting two distant points in spacetime. In 1988, physicists Kip Thorne and colleagues proposed that if one mouth of a wormhole were accelerated to near light speed and returned, time dilation could create a difference in age between the two ends. Step through, and you might emerge in the past relative to your entry point. But here is the critical issue. We have never observed a stable wormhole. There remain mathematical possibilities, not engineered realities. Thorne himself wrote, although the laws of physics allow time travel, the technological requirements may be beyond our reach. Now let's examine the conspiracy layer. One of the most famous alleged time travel stories is the so-called Philadelphia experiment. According to the legend, in 1943, the US Navy conducted an experiment to make the USS Eldridge invisible. The story claims the ship teleported and crew members suffered horrific side effects. The tale first appeared in letters written by a man named Carl Allen in the 1950s. However, naval records and independent investigations found no evidence supporting the event. Historian Robert Goeman investigated the story extensively and concluded, there is no documentation that such an experiment occurred. The Office of Naval Research stated plainly that the experiment was fiction. Yet the story persists. Why? Because secret government time experiments are compelling narratives. There are also modern viral claims. Online, videos sometimes show supposed time travelers in old photographs holding modern-looking devices. One famous example is a 1941 photograph taken at the reopening of South Fork Bridge in Canada. A man appears to be wearing modern sunglasses and clothing. Researchers later showed that his outfit was entirely consistent with 1940s fashion. Extraordinary claims often collapse under ordinary scrutiny. But let's return to physics. Stephen Hawking addressed time travel directly. In 1992, he proposed what he called the chronology protection conjecture. Hawking wrote, "The laws of physics conspire to prevent time travel on a macroscopic scale." In other words, quantum effects may destroy wormholes before they can be used as time machines. Hawking even hosted a party for time travelers in 2009. He sent invitations only after the event, reasoning that if time travel were possible, someone from the future would attend. No one came. It was humorous, but it made a serious point. If backward time travel were easily achievable, we might expect evidence of visitors. We see none. There is also the paradox problem. If you travel back and prevent your own birth, how do you exist to travel back? Physicists call this the grandfather paradox. Some theoretical solutions suggest branching universes. That brings us to the many worlds interpretation of quantum mechanics, proposed by Hugh Everett in 1957. In this view, altering the past creates a new timeline rather than changing the original. But again, this remains interpretation, not observable proof. So where does that leave us? Forward time travel is real, measurable, and experimentally confirmed. Backward time travel is mathematically possible within certain solutions of Einstein's equations, but remains physically unverified and potentially forbidden by quantum effects. There is no credible evidence of secret government time machines. No verified human traveler from the future. No authenticated historical anomaly that withstands scrutiny. Yet the fascination continues. Why? Because time defines existence. To control time would mean to control destiny. It is the ultimate power. Philosopher David Lewis once wrote about time travel. The very possibility forces us to rethink causation itself. Time travel is not just physics. It is metaphysics. It challenges how we understand cause and effect. But science demands evidence. And so far, the evidence supports limited forward time dilation and nothing more. Still, physics is unfinished. Quantum gravity remains unresolved. Black holes continue to challenge our understanding of space-time. As physicist Carlo Rovelli writes, our understanding of time is still incomplete. Perhaps the future of physics will surprise us. But for now, time travel belongs partly to science and partly to imagination. And that boundary is where this series lives. Next episode, we move from physics to theology and extraterrestrial speculation. Was the Garden of Eden an alien spacecraft? We will examine ancient texts, symbolic interpretation, and how modern narratives reshape sacred stories. Thank you for watching. If you found this exploration valuable, please subscribe, like this video, and share your thoughts in the comments below. Your engagement fuels our journey into the unknown. Join us next time as we question everything. This is Curiosity Kenyon. Stay curious. Stay vigilant.